classes. Great. So now we're recording. So the whole purpose of this chapter, um, and specifically these slides are from another book, but sometimes I do put slides from this other big Java book up, even though the main textbook is the um, listed up here, How to Think Like a Computer Scientist, right? So there are definitely chapters in here about object-oriented programming because that's what designing classes means. That's what objects means. Reusing classes. All of this whole thing is object-oriented programming. But there are some slides that are pretty good, I think, from this other textbook. That's why I keep using them. And then, of course, on the syllabus, there are also some good tutorials from the actual um, creator, like the owner of the Java brand, which is Oracle. So that's why on the syllabus, there are lots of different resources, right? Like as we go through the syllabus, there are links to the textbook, and then there are links to um, Oracle tutorials, and all of them are very useful. So let's get back to this presentation here. So we've got this transfer with an amount and a bank account. So we're saying, all right, subtract the amount from the balance, and then the new balance is going to be the other balance plus the amount, and then the other account is equal to a new bank account. Well, this won't work. It's not a good design decision. Okay, so what we need to do is we need to design the classes so that you can make a balance change, and then the change will be reflected in the proper object, right? So in order for this to work, sometimes you have to give preconditions. And one precondition could be only accept for a deposit if the amount is greater than or equal to 0. I mean, a bank might even say it's silly to make a deposit if it's 0 money, because then what are you doing? Waiting in line and you're just putting on a deposit sheet $0? So if the precondition is violated, the method is not responsible for computing the correct result. It's free to do anything. So one thing you can do is you can throw an exception. You can say, all right, if the amount is less than 0, throw a new illegal argument exception. Then change the balance. Okay? So the method doesn't have to test for the precondition. If this makes the balance negative, it's the caller's fault. Right? So it's all about deciding where in the program are you ensuring that the user can't do this. So somebody can't walk in and say, okay, I'm making a deposit for negative $1,000, and then the bank has to hand them $1,000. So you can have a method do an assertion check. This is some new syntax you've never seen. You can assert that the amount is greater than or equal to 0. And, you could use an if statement. If the amount is less than 0, just return. The textbook author doesn't recommend this, that it's hard to debug. But there does need to be error checking. If you're not checking for these sort of things, then your program's not going to work as intended. All right? So you can turn on assertions, and then if this condition is false, an assertion error is thrown. Okay, post conditions are conditions that are true after a method has completed. So if it's in accordance with the preconditions, it must ensure that the post conditions are valid. All right, so you can check that the return value is computed correctly, that the object is in a certain state after the method call has completed. So we can see here we're depositing money into this account, and the post condition is that the balance is greater than or equal to 0. And then the precondition is that the amount is less than or equal to 0. So you cannot put negative money as the deposit. So here we can use amount is less than or equal to get balance. This is the post condition. And the contract is if the caller fulfills the precondition, the method must fulfill the post condition. So if you already have a positive bank account and you're putting in a positive deposit, there's no way you can be negative, right? So why might you want to add a precondition to a method that you provide for other programmers? Then you don't have to worry about checking for invalid values. It becomes the caller's responsibility. Okay, so that's a lot of good discussion about design. Now let's actually do some designing. So let's go here to Replit. And let's go here to create a REPL. And we can call this one Design Fall 2021 AM. Okay. So let's make a class. Let's make a class student. And let's keep track of all the grades inside of a array of doubles. So we can have here, well, no, we'll use an array list. Array lists are good. Good practice with array lists. So we'll say import java util.arraylist. Array list of doubles grades equals new array list. And we'll have a method, create a method add grade that checks if the grade is 0 or above, right? Do not accept a negative grade. Okay, and then we'll say create a method calculate average with 90 and above is an A, 80 and above, right? 80 and above is B, 70 C, 60D, and all the rest is F. Okay, so that's calculate average. And I guess that should do, because it'll take time to do this stuff. Now, do not accept a negative grade. So you can use any of the things we just talked about, right? So what are the things that we just talked about? Let's review. You can use the thing he said not to. You can use an if statement, right? I'm okay with that. You can use an exception. Okay, that's fine too. And you can use an assertion. Okay, then you have to turn it on. That's probably like the biggest pain, but it's not a big pain at all. So you pick which one you want to use, but just make a method add grade that checks if the grade is 0 or above before it adds. And this will take some time, right? It takes some time in order to set all these things up. But I really like when students do attempt these things. So there's good participation, but there could be better participation. So if in the past you've not done these exercises, definitely start. That's the key. And then the last thing is at the main, create a student and add some grades right? Because you have add grades. So it's basically call add grade multiple times. And then you're going to call calculate average. And then we'll see if it works, right? We will see if it works. Okay, questions about this before you get started programming it? Okay, awesome. So it's 7:19, so we'll take some time to do that. Okay, great. So got the recording going again. Now, I was just like randomly picking students to ask how progress is going. So I'd write one and say, "Oh, how's it going?" No response for minutes, and I think, "Oh, maybe the person is just not there at the computer, right?" But they'll come back, and then no response, no response. So I send it to other students. So I really think there are a number of people who just sign in and then like maybe there's benefit to requiring people to put the cameras on because then you have a better idea that people are on in front. My thinking was always that the camera is a distraction, but maybe there's good benefit to that because it forces people to just at least stay in front of their computer instead of just who knows, like maybe they're playing volleyball at the beach now, I don't know. But you know, the idea is that you're going to be doing these things, and it's pretty hard to do them if you're not like in communication. So the student here that we're going to use, and I'm sure some other people did the example as well, but the student here has an array list inside of the class student, and we see that there is add grade using an assertion. Now, when I messaged the student said, "Oh, I don't know if I'm doing assertions correctly because it's adding the negative score." And I said, "Well, everything looks good with what you're doing. Like nothing looks bad." 1 second, please. Hello? Yeah? No, it should be on the seat next to you. Yeah, it should be on the seat. I took everything out and just put it on the seat. Did you find it? Okay, bye. It's definitely there. Okay, yeah, sorry about that. So we do have this assertion used correctly. The only thing is when you call this project, you have to type Java -EA main. Okay? And the idea is when you do these sort of things, things can go wrong, right? You try to work with an assertion, it doesn't work. You try to work with an assertion, it doesn't work. The great satisfaction for me as an instructor is when you keep trying something, and then you get it. Because that's just a very rewarding feeling for me that you're able to keep trying, and then when you finally get it, it's then yours, right? Like now you're able to use this thing. So the grades are being added correctly, right? Because the assertion does work. We see down here, we should talk about calculate average. Calculate average is going to need to go through the entire array, array list. And for a nice for each loop here, for each one of the grades, we're going to be adding it to the total, and we're also going to increment the count. You could also use just the size of the array list, but count is fine too. And then the average is going to be the total divided by count, and now we just have our series of if statements. If the average is greater than or equal to 90, we put it as an A. Else if 80, B. Else if 70, C. else if greater than 60. Ooh, this is a little mistake, but that was probably from copying and pasting, not a big deal. We just changed that to a D. And again, if you're looking for this link, here's this link. I just forked the student's account just so if I make any changes, then it's not a big deal. So then we have here, it's a void, so we're just printing it out, which is fine. And then we'll just change this. Your average grade is, and then down here in running it, we make our student. We just call it a few times, like 3 times is great. So we have 150 and then negative 50. Now, to just run it, it will enter the negative score, right? Your average grade is 33.33333, which is an F. But if we run it with Java EA main, that means EA stands for enable assertions. Okay, EA stands for enable assertions. And you see how it will not let that go through. There is the assertion that breaks this problem. Okay? So, does this make sense? So, if anybody has any questions about this, now's the time to think about, to ask them. Okay, no questions, just we need to practice more. Okay, sounds good. All right. So, let's go back here to Memer. I got a message about Memer. And with Memer, you do have the late days for the IDE scavenger hunt and your object-oriented first assignment. The object-oriented first assignment definitely does relate to the things that we've been doing. So I'm gonna put in more time for both through the 20th. Yeah, let's do that. All right, so let's make the due date through, let's make it due through tomorrow for object-oriented first assignment. And then we go back here, IDE scavenger hunt. So I'm actually making the due date later because in my in-person class, what happened was in my in-person class, I gave an exam, and can I show with scanner? Yeah, we could add a scanner to this. So in my in-person class, we gave the exam and actually told them on Discord that they have 2 assignments due, but a lot of students, I just looked there, didn't do it. Now, I told them from the beginning that Discord is a big part of being in this class. Like, even though I meet with them in person, I also communicate with them through Discord. So I'm going to remind them one more time today on Discord that these assignments are due. But you know, we only meet once a week so they can have more time to do these things. I meet with you twice a week. So I don't know in the end which is going to be the best approach because things are a little bit different. Like if it was meeting twice a week in person versus meeting twice a week online, that's probably a little easier to make that comparison. But I'm meeting with them once a week, and then I message them on Discord, but they're not necessarily all signing in to see it. But then again, in here we have people who are signed in but not really in communication. So I don't know. We'll see in the end which is the best result. So there was a request to allow a user to keep adding it in with a scanner. So we can just go here and say scanner equals new scanner. And we'll just read it in from system.in. And at the top, we can just add in the scanner, import java.util.scanner. And then we can say here something like, I don't know, let's see. Do we want to just do it a certain number of times, or we'll just do it while they don't say to quit. So we'll say string name equals this, and we'll say while name doesn't equal quit. Okay, so while the name doesn't equal quit, we'll just keep reading it in. So we can put in here system.out.println, enter the name. No, wait, we're not doing names. Enter the grade. Enter the grade. So enter the grade. So that has to be an int grade equals 0. And we'll say while the grade is greater than 0, we'll continue. Okay. And we'll say enter the grade and use -1 to quit. Okay, so that sounds reasonable. So then in here we're going to say grade equals scanner.nextInt, and then we can put grade equals scanner.nextInt. Then we can send this grade to the student. So we're going to say stu1.addGrade. So we'll say stu1.addGrade. Oh, and that takes in a double. So that has to be a double. And these are just little tweaks you have to do when you're making the problem, you know, like coding your solution. So we can take these out, and we can actually calculate the average each time. And let's see. We definitely also don't want to add the grade if it's less than 0. So we can say if grade is greater than 0, then add the grade. And also calculate the average. Okay, that looks good. And then at the end, I guess we could just do like a final thing. Final grade. Final grade. Final results. And then we'll just print out stu1.average. Calculate average. And that's not a print statement, that's just a... Okay, so let's give this a try here. So we run it, and we have to run it with assertions. So we can say here, Java EA main. Okay, final result is your average grade is not a number. let's see. Oh, yeah, I see. Has to be an equal sign in here. I did while grade is equal to 0, while grade is greater than 0. Yeah, that definitely wouldn't work. Okay, so let's try that again. Java EA main. Let's see. Still have a problem here. So while grade is equal to 0, while grade is greater than or equal to 0, did I not compile it? Yeah, I probably didn't compile it. Yeah, I think that's the problem. I didn't recompile it. Yeah, stupid. Okay, Java C main.java. There we go. Java EA main. Okay, enter the grade. Good. So the student got 100. Your average grade is 100. Okay, they got a 90. You have a 95. All right, good. Now we'll give them like a really low score. They get a 30, 73, which is a C. We do -1. Good. Okay, so the problem was I wasn't compiling after the changes. That's why there was the delay at the end a little bit. But we're all used to with Replit just clicking on run, right? Like we're used to just clicking on run. Now with EA for enable assertions, we have to go to the command line. We are going to the command line. Now, we just are working on an exercise now about the command line, okay? We're working on an exercise with the command line. So that's why, like going here and typing in EA, this is all interconnected, right? It's interconnected. We're talking here on Memer about this scavenger hunt, right? So you go here to the scavenger hunt, we say sandbox, open Memer IDE. Okay, and then we go here to assignments, fall, and let's see, where was the one about the, was it under desserts? Open find blame, cat, no, that wasn't the one I wanted to talk about. Let's see. All right. So this, oh yeah, this was about moving. And then that's clear. Let's see. CD personal. Oh yeah. This is the one. This is the one where you had to concatenate them, right? You had to cat these 3 files into the output files. Okay, so if we go here, we can add these 3 shreds into, like a diploma. So we would say something like cat shred1.txt, shred2.txt, shred3.txt, shred4.txt, and we send it into diploma2.txt. And then we can say open diploma2.txt, and we see, it's kind of funny because sometimes students will send me messages and say, oh, I did the instructions and it's just nonsense. Like there's no sense to it, right? And yeah, if you read like period D, DP, it doesn't make sense. But if you look at all of these as ASCII art, right? Then it becomes a number, 1964. So part of the assignment is just thinking like kind of outside the box, right? Like you're not only reading the results of period dot space D capital P quotation mark YB. And a lot of students, of course, figured it out, right? Like it's not like every single person wrote me that message, and I'm happy students did write me that message, right? It's fine that people are going through it and they're not sure on something and they want to ask me a question. That's good. I have no problem with that. So, like as you do these things, you're getting more familiar with just working in the terminal. So even though if you look at the class title, it's called Java Programming. Java programming does involve some use of the command line, right? We do go over here in Replit sometimes and have to type out Java space EA main. That's something that could happen. All right. So in this case, the assertion is probably not going to be used because we're doing the if statement, but assertions are really, really useful because if somehow we start using this, oh yeah, the coordinate insults were funny. They were, I think they put a lot of effort into it. If we use add grade somewhere else and we don't properly check, that's why the assertion is in there. The assertion is like a fail-safe. So, all right, I really enjoyed looking at these assertions, and hopefully you were able to do the example. I see I got some messages here, but I'll check those later. Probably it was just about this assignment here. Okay, so let's close this here. Let's close this here. And let's close this here. Close this. And then we'll move on over here to exceptions. Okay, so let's get back here. So the term exception is shorthand for the phrase exceptional event. An exception is an event which occurs during the execution of the program that disrupts the normal flow of the program's instructions. When an error occurs within a method, the method contains an object and hands it off to the runtime system. The object, called an exception object, contains information about the error, including its type and the state of the program when the error occurred. Creating an exception object and handing it to the runtime system is called throwing an exception. After a method throws an exception, the runtime system attempts to find something to handle it. The set of possible somethings to handle the exception is the ordered list of methods that have been called to get the method where the error occurred. The list of methods is known as the call stack. See the next figure. So we have here method where the error occurred, method without an exception handler, method with an exception handler, main. Okay, so the main is calling this, which is calling this, which is calling this. The runtime system searches the call stack for a method that contains a block of code that can handle the exception. The block of code is called an exception handler. The search begins with the method in which the error occurred and proceeds through the call stack in the reverse order in which the methods were called. When an appropriate handler is found, the runtime system passes the exception to the handler. An exception handler is considered appropriate if the type of exception object thrown matches the type that can be handled by the handler. All right? So the exception handler chosen is said to catch the exception. If the runtime system exhaustively searches all the methods on the call stack without finding an appropriate exception handler, as shown in the next figure, the runtime system and consequently the program terminates, which is what we saw when we sent in a negative value when assertions were enabled. Okay? So, throws exception, the method where the error occurred. Now it's looking for the appropriate handler. So it forwards the exception to a method without an exception handler. It's looking for the appropriate handler. It catches some other exception. Okay, it's searching the call stack for the exception handler. Okay, so we move on. Now, you may want to catch your exceptions. So the try statement tries some code, and then the catch has to deal with some of these possible exceptions that can come up. Okay? So there are different kinds of exceptions. The first kind of exception is the checked exception. These are exceptional conditions that a well-written application should anticipate and recover from. For example, suppose an application prompts a user for an input file name, then opens the file by passing the name to the constructor for java.io.fileReader. So, normally the user provides the name of an existing readable file, so the construction of the file reader object succeeds, and the execution of the application proceeds normally. But sometimes the user supplies the name of a non-existent file, and the constructor throws Java IO file not found exception. A well-written program will catch this exception and notify the user of the mistake, possibly prompting for a corrected file name. Okay? So checked exceptions are subject to the catch or specify requirement. All exceptions are checked exceptions except for those indicated by error, runtime exception, and their subclasses. Now, we need to talk for a minute about how people learn how to program. So, all of these things are human creations, right? The division into checked exceptions, unchecked exceptions, error, runtime exception, all of these things are people getting together and deciding, this is how we're going to handle this is how we're going to handle this. It's different from the laws of physics, right? Where, you can derive equations. There are probably certain types of intellectual minds that just prefer that world, right? Where there's no reason why it has to be written out runtime exception, except that's the way the programmers decided to make Java. That's the way the language developers decided to make Java. And there's a certain amount of practice you need to do to keep getting better at this, Now, getting back to the initial question about the exam, because you're going to be limited by time, probably the question about the exceptions would be just something like, what is an exception? And then you have to write, an exception is a block of code when something went wrong that the user can either deal with or not deal with. A checked exception versus an unchecked exception. You just write something that indicates that you know what an exception is. All right, so I like short answer questions. I do like short answer questions. And they're going to be short answer in a certain block, like a certain amount of a response that you can give in a brief period of time, right? So one of the questions I asked my in-person class was just, what is a constructor, right? What is a constructor? And then give an example. So lots of students would say good answers like, a constructor is how data is passed to a specific object. Constructors are created inside of the class with the same name as the class. And they gave an example with something like class student, and then inside there they have student. And I'm just, typing something like that. Like that is a constructor, right? So that would suffice. And then that would be a good answer. And then someone else might write something like, a constructor is in an object. That was an answer I got. A constructor is in an object. Well, that's not really explaining very well. That's just sort of words that are kind of on target. Like they did put object in, but objects, it's not the proper relationship. So with very brief short answer questions, I can really understand, has the student been reading along in the textbook? Have they been doing lots of examples? And there will be some brief code snippets too. Like you will write some brief code, but the short answers are good also. They really indicate if you've been, following along. Okay, so we can go ahead and stop looking at this because I'm looking at the time. It's 8:23. And we can stop looking at these slides too because we're really running short on time. Now, if we go to Freer School at Java MDC, we can see under today's date that I've added in your next code review. And this is just like going back to the old code reviews. And I wanted to, before time runs out, go to codewars and show you something. So let's just go to a Java problem, and we'll look at level 7, and we'll look at kata I have not trained on. Okay, let's take a look at aerial firefighting in Java. Okay, so it says you are an aerial firefighter, someone who drops water on fires from above in order to extinguish them. And your goal is to work out the minimum amount of bombs you need to drop in order to fully extinguish the fire. The fire department has budgeting concerns, and you can't just be dropping tons of bombs. They need that money for the annual Christmas party. The given string is a 2D plane of random length consisting of two characters. X representing fire, capital Y representing buildings. Water that you drop cannot go through buildings, and therefore individual sections of fire must be addressed separately. Your water bombs can only extinguish contiguous sections of fire up to a width parameter W. You must return the minimum number of water bombs it would take to extinguish the fire in the string. Note, all inputs will be valid. Okay, so we go here to train, and this is one thing I wanted to point out. One thing is there are assertions. It says assert equals 3 and then the solution water bombs. Okay, so let's see. So the width is 4, so we can take out 1, 2, 3, 4 fires. Okay, so this one's fine, and then this one is fine, and then this one is fine. So that's 3. So I actually did want to solve one problem with you, just to sort of reminisce with you how I handle these sort of problems. And I think that this one is pretty similar, just by chance, to the previous one where split is a great way to start. So I think split is a great way to start here. We can say string array fires equals, we'll take the fire and we'll split it based on the capital Y, because the buildings get in the way. So then we're going to have int count equals 0 for string f within fires. Now, we have this individual fire here, right? And we need to know how many times can we put this number, this W, into this fire? Like, if we would have had 5 here, 5, guess what? You would have to drop 2 of the water bombs. Is that what they're calling them? Yeah, bomb. They're just calling them bombs. So we have to see how many times can it can it go into it. So let's think the best way to figure this out. Int division equals the, there's nothing else that can be sent in. It's just x's and y's, right? So we can say f dot length divided by w, but we want the ceiling. We don't want it to just stop. We don't want to just get the regular division here. So we can say here double and then math dot ceiling. Okay, let's see if this works. And then we can just add that to count. Count plus equals division. All right, let's see. And then we return count. I don't think it's going to work the first try because this one seems a little tricky, but let's see. Oh, yeah, and then I had to recast this back to ints. So let's try that. Oh, it actually worked on the first try. Okay, let's try the other attempts. Okay, great. I'm really happy. So that worked a lot faster than expected. Now, the great thing is, what we can do here is we can compare what we did with what everybody else did, right? So it always makes me feel good when I see like somebody who has to do line after line after line after line, and it's like you realize that this person was really, really frustrated, right? They were just totally like losing it. They were saying, "Oh my God, I don't know what to do next. I don't know what to do next." And everybody has been there, right? Like everybody has had that feeling when they're solving problems. But I'm telling you, the more problems you solve, the better you get at this, right? Look, it says completed 1,081 problems on this site. If I didn't do so much programming, I wouldn't be able to just sit down and do aerial firefighting in 2 minutes, just like that, while talking through the problems. That's the idea. You have to keep practicing. I'm just trying to remind you of that. Every week you need to find time to sit down and get better at this, get better at this, and it's going to help you no matter which direction you go, right? Like let's say that you want to go into IT and you think, "Oh, programming's not for me. I just want to solve problems with IT." Well, problem solving in general is going to be helped by this, and in IT, you'll be writing some scripts. In IT, you will write some scripts. And let's say that you decide to go into the hard sciences, like you do want to become a physicist. We were talking about deriving equations by knowing calculus well and understanding these core basic principles. Well, guess what? Physicists use computers. Physics uses programming. So you can't evade programming that way. If you go into business, so many businesses are incorporating artificial intelligence and these huge intelligence systems into their operations. Knowing some programming and problem solving will be helpful there. Now, are you going to be asked to like solve a problem like this generally in a business environment? No, but you might need to be able to split through data, to iterate through the data and make some sort of calculations, then return it. Unless you're going to be like studying poetry at some point in your life. I mean, could programming help you with poetry? Probably not. I mean, maybe you're analyzing other poems for certain things, but that's like a pretty big stretch. For the most part, I think programming is going to be really, really useful for you going forward. Okay? So keep in mind as you're solving these problems on codewars that this is how you get better. So the reading, the vocabulary, that's good too, but problem solving is so important as well. You just have to keep doing problem solving, Okay? And then when you finish, you just write up what you did and you click here to add submission, and then that's good. So we've definitely done that before. So that's that. And Okay, so that example went quicker, so let me take attendance and then we'll be done. So let me just go ahead here, take the attendance. All right, so we are on 1018. Yes, 2 from codewars. Okay, almost done. All right, that's attendance. So see you on Wednesday.